Hello, welcome to Designs for the Edge with Microchip Technology, our latest live stream series in which we talk about fast-growing markets and the technologies that are enabling them. I'm your host, Eric Glatfelter. Thanks for joining us today. We are live streaming on several platforms. Feel free to ask questions and we'll get to those at the end of the live stream. Also, please like, share, and subscribe. Our topic today is 5G technology trends. Joining us remotely is Neelam Ruparelia. Neelam, welcome to Designs for the Edge.
Eric, thanks everyone for joining today.
Neelam, for our viewers, would you take a moment and describe your role or roles here at Microchip Technology?
Yes, many of us wear double hats. So, yeah, so I lead our go-to-market efforts and market strategy for two of the growth megatrends or verticals that you can say, specifically for 5G and AI. Those are the two megatrends that I focus on.
Okay, thanks. So let's talk 5G. So first of all, how does 5G compare to 4G? Can you walk us through a little bit of the history and maybe some of the benefits that 5G delivers versus 4G?
Yeah, absolutely. I think that's a very interesting question. So if you go back a little bit, cellular phone were novelty back in 1G, 2G era, but with 2G to 3G was primarily about adding data or enabling, let's say, browsing, basic browsing capability, but mostly about adding messaging capability. When that capability took off and consumers were really enamored with that, the industry came up with 4G saying, let's provide more data. And so 4G is where most of the phones were able to say, not only take pictures, but upload pictures or videos or having, let's say, even video calls live with the 4G bandwidth. So when it came to 5G, it was no longer interesting to just increase the data bandwidth. And so the industry raised the bar and say, okay, now that we understand that if you have more internet connectivity, consumers can find many applications, we need to raise the bar with 5G to make 5G, ubiquitous and accessible almost anywhere. So I'll give you an example. When you buy a new light bulb or Wi-Fi router or something else for your house, you don't think about, hey, this is a 10 watts power, or this is 30 watts power, or this is 250 watts power. You just buy the thing and just plug it in the socket in the house. And so that was the goal for 5G, saying, hey, let's connect anything and everything that's feasible to connect and useful to society. And that drove the goal for 5G to raise, the usefulness of internet connectivity on many different spectrums, on many different dimensions.
Okay. So in that sense, it's sort of tied in with the Internet of Things and just many, many more devices becoming connected, whether they're high bandwidth or not?
That's right. That's right. So again, low bandwidth devices were connected at 4G as well, but the 4G network was not designed for it. So yeah, you could connect it, but it wasn't cost effective for carriers, and it wasn't really meant for that. It was mostly meant for mobile phone. With 5G, the idea was to create a network that can connect anything and everything, and also not just that, offer real-time applications as well in massive scale.
Okay, so those real-time connections, that gets to the bandwidth and the latency of 5G, is that right?
That's right. So I think what those goals of making ubiquitous and accessible translated into was really those three dimensions, right? So when it comes to technical implementation of 5G, the industry decided, okay, let's go up on three different dimensions. So first of all, increase the bandwidth. So that was more linear. So 3G to 4G, the bandwidth increase as well for the cell phone. And the 4G to 5G, the goal is to increase the bandwidth another 10 times for mobile broadband. But that was one dimension. The other dimension is to increase number of connections. So like we discussed, connect all kinds of IoT devices, gas meters, cars, everything else, and enable the network to make those connections easy to happen as well as reliable to happen. And the third dimension, which is brand new for 5G, is to reduce latency. Now, latency is a term that needs a little bit of explanation. What latency means is actually whenever you use your phone or any device, you request information from a server. So the amount of time it takes from the action you take, push a button or initiate a dialogue, dial a voice, video call, to actually making connection and getting response back is called latency.
Right.
So reducing latency 10 times compared to 4G enable a lot more real-time mission-critical applications for 5G.
Okay.
And so these are the three dimensions where 5G is raising bar over 4G, let's say.
Okay, so just to talk through that latency a little bit more, we were talking about ADAS a couple weeks ago on this live stream, and we were talking about the difference between, for example, pushing a button that raises or lowers the window. A little bit of delay is not a big deal, versus a safety critical function where latency has to be a minimum. And then maybe in this realm, if I'm sending you a picture of my dog or something, it can tolerate a little delay. But when we're talking over the air like this, we want everything to be instant.
That's right.
Okay.
That's right. So, and there are many other examples like that, right? So people have talked about even remote surgery. That seems a very niche and unique example, but a more common example likely is a remotely driven vehicles, right? So, there is self-driving car, and the self-driving cars are likely to happen. They're likely to be, depending on the company you talk about, Tesla or Waymo or somebody else, they are less or more likely to be dependent on the connectivity. But there is other type of remotely driven fleet that are more likely to happen, which is, let's say, not even passenger cars, right? Trucks.
Sure.
Trucks transporting cargo or goods from one location to another. Pepsi Cola moving from distribution point to warehouses in the cities. Those type of vehicles are becoming, or at least getting there to be driven autonomously for the most part, but they're monitored by a remote attendee or remote driver. And for the most part, those vehicles will drive themselves from A to B, but there will be times when they need help. And when they need help, it becomes real time, right? So that's the kind of real time safety critical applications that are enabled by 5G. Those feasible with 4G, but not so reliable. So now the 5G makes it a lot more reliable. There's another interesting example, which is also not so safety critical, but shows the importance of time. So for example, you're driving by a new city on a vacation in the summer, and you're driving by interesting looking building, historical building. You wonder what that is.
Right.
And people see, if you have a Google glasses or AR glasses, there is likely to be a feature on that connected to 5G, which shows you the history of building. And people have debated about glasses, but those things can also show up in your windscreen.
Sure.
And in that application, it's not safety critical, but the time window is important to be real time. Otherwise, that application has no meaning.
Right. Okay. Or other just navigation or trying to find things about the locale you're passing through. Interesting. Okay.
That's right. That's right. You're going to see people trying to deliver pizza to your home. And I've seen, believe it or not, I've seen in the street of San Jose, and people talk about drone, but leave aside the drone, there's actually a small robot running on the street trying to take a delivery from one place to another.
Yeah.
And that's a real time. Somebody has to remotely monitor it and make sure if the robot fell off, fall down or something, bring it up or send somebody or et cetera, et cetera.
Yeah, and
So yeah, there are many more applications that are coming.
I want my food to be warm when it gets there. So
That's right. That's right.
no delay,
Yeah,
no
yeah,
delay.
yeah.
So, okay, so
Yeah.
we've been talking, 5G's been a term in the industry for quite a while. Obviously, that's a very extensive build out. Where is the industry in that rollout or build out of 5G?
Yeah, that's a good question. So, 4G, there is a term for 4G called 4G LTE. And the expansion of the acronym LTE is long-term evolution. and we are past that. So what I'm trying to say is that LTE, 4G LTE planning started in 2005, 2006 timeframe. The deployment started in 2010, 8 or 9 timeframe, went up to 2018 or something. And that was called long-term evolution. 5G is similar and probably going to be even longer term. So today, 5G has started deployed in, let's say, advanced countries, economically advanced countries. Probably about a quarter or a third of the networks are 5G upgraded.
Okay.
And so there's still more than half upgrade to go. In not so advanced countries, probably no more than, on an average, no more than 10% of the networks are upgraded. And this is networks. And once you upgrade the networks, then you can sell the cell phone, 5G cell phones, but if the network's not upgraded, people don't want to buy it. Now the networks are upgraded. You're going to find a lot more 5G cell phone coming. And that is another cycle that will happen. So overall, we think, let's say about 4 to 7 or 8 years of more deployment on the network, and probably another 10, 12 years of new cell phone selling cycle that likely to go on for 5G.
Right.
So we are kind of less than middle, let's say third inning or third inning in the baseball terms.
Okay, so still a long way to go. And you mentioned
Yes.
the network, and that raises a good point too, because when I say 5G, right, I think of the tower, the radio tower, but there's really an extensive network and infrastructure behind that. Can you talk
That's
about
right.
what's needed for that build out a little bit?
Yeah. There's there we can also see the difference between 4G and 5G. So yeah, so
Okay.
this slide is really timely. When you use a cell phone, all you see is cell phone, and you can intuitively grasp that, okay, your phone is connected by airwaves to the cell tower, and you're driving by freeways or street side, you see those cell towers with rectangle vertical boxes showing up on the tower. And so the phone connects to those towers. Those what you see are antennas that are radiating airwaves to connect to your phone. But behind that, there's a vast amount of network that goes. In case of 4G, it used to be very simple. You have a radio up on the tower and or at the bottom, and there used to be something called base station at the bottom that connects back to backhaul. To make those three-dimensional progress happen, for 5G, this network became even, an order of magnitude more complex. And so the network behind that needed higher amount of bandwidth and also more number of equipments, and split into multiple steps. So what you're seeing in this picture is the network behind the radio towers, which is called front haul, which connects radio tower to the next point, which are DU or distributed unit of the baseband, which then connects CU of central unit of the baseband, and then the backhaul network and the core network. So this is a very simplistic picture of 5G, and used to be even lot more simple in case of 4G. You can see the complexity increasing with this network.
And each one of those pieces is extremely complex by itself.
Yes. Those equipments cost, radios will cost maybe a few $1,000s all the way to tens of thousands of dollars. And eventually the carriers like Verizon, AT&T, Deutsche Telekom, China Mobile, they end up spending in the tune of, as an industry, in the tune of 50 billion to 100 billion a year over a period of 10 to 15 years to
Yeah.
make this entire network happen.
Okay, significant investment there. So as we
Yes.
look across that whole network, what, and we're building these infrastructure pieces out, what are the common design challenges? What are the biggest areas of design considerations that people need to think about?
Yeah, there are so many of them, and the industry has been trying and addressing those for almost 5 years now. But let me put it this way: there are about to increase that 10x on 3 dimensions. There are about 300 or so that I have seen some list somewhere, that 300 specific point innovation. So for example, antenna design and antenna power supply and the tower design, and then you have this baseband devices that are split into DU and CU and their own design, both in terms of the silicon as well as the software,
Yep.
and then things around that, which is power and the fiber connectivity and so on. So yeah, roughly in the order of 300 or 400 specific innovations that's been built into enabling this network, and we do our small part of it as well, as you
Yep.
can see this blocks down there in this slide.
Yep. So what are the main areas that Microchip technology is investing in? So let's talk through a couple of those. Let's talk RF first on that very front end.
Yeah, so very interesting. So what happens with 5G is, because you want to increase again the bandwidth by 10x, you can't do that with existing spectrum or the airwaves that were used for 4G, because 4G continues to be there as well, and you're adding this in parallel. So first of all, there's more spectrum added.
Okay.
And in 4G, it used to be only up to, let's say, 2.5 gigahertz or 3 gigahertz spectrum that was used. With 5G, that's been raised to 3.5 all the way up to 6 gigahertz, depending on countries and deployment. But beyond that, to enable much higher bandwidth on a local basis, 5G is using bandwidth above 10 gigahertz. So for example, 11 gigahertz, 18 gigahertz, 22 gigahertz, which are microwave range, and then beyond that up to millimeter wave range, which is all the way to 50, 60 gigahertz. So what Microchip has done is we're focused on that niche area specifically for RF, enabling the microwave and millimeter wave. We provide the technology and component solutions for those applications where the microwave millimeter wave is enabled for 5G usage.
Okay.
And then, yeah.
Okay, so the second area would be, I wanted to ask you about, is security. And this has come up in basically every discussion that we've had in Designs for the Edge about key markets. We say anything that's connected needs security. 5G is all about connectivity. So how important is security here, and what does Microchip technology offer to clients designing systems in this space?
That's right. So yeah, so security is hugely important and becomes even more important in this era of AI, as we all know. Specifically for 5G, you have to think of security in terms of layers. And as you know, we provide a whole spectrum of solutions for security. But when you think of 5G, the traditional thinking in 4G and 3G was that, hey, I have a cell. My radio is on cell tower. A cell tower is, 30, 50 feet high. Nobody's going to, reach there and try to manipulate that equipment. And so the need for security was less intense in 4G, and you could get by with a basic security chip in a radio or in a baseband. But when it comes to 5G, again, to enable this high amount of bandwidth and high amount of real-time applications, there's a lot more small cells being deployed, and there's a lot more what's called fixed wireless access that actually is one of the big revenue earner for 5G. Those devices hang out on the side of a building and outside of your home, for example, for fixed wireless, or outside building in a downtown city block.
Okay.
And those are a lot more accessible for nefarious actors. than than radios.
Yeah.
And this is the reality of life. So what you have to do is, for small cells and fixed wireless, etc., you have to put in, let's say, more stringent security solutions. You have to think of 2 or 3 layers of security as opposed to just single layer of security as you would think on in the 4G case. So yeah, so and in those security aspects, we offer the whole gamut of solutions, all the way down to very basic, simple security that can be in few tens of cents in terms of chips, all the way to multi-layer defense-grade security or infrastructure-grade security that can also be customized by our customers. And that's why we are one of the top supplier of security solutions in this industry.
Right, and you mentioned layers there, and there are hardware and software layers available, right?
Yes, absolutely,
Okay.
and that's one of our philosophy. We don't just make chips and provide chips, right? We
Yeah.
provide hardware layer, of course, and on top of that, software layer. But also, more importantly, we build solutions that keeps the network in mind. So it's not just a point solution. Our security solutions will not just think about, hey, this chip or this device needs to be secure, but it needs to add to the security of the network, and it needs to enable the upper layer of the software to maintain the security at every layer.
Right. Okay. So let me ask you about 2 more areas of challenges and solutions. The first would just be on the protocols, the networking protocols like Ethernet. So time-sensitive networking is kind of the new emerging
That's right.
technology there.
That's right. That's right. So that's a very, very important point. So one of the things that happens with 5G, as we talk about, is it's the same network that is supposed to carry, somebody trying to upload a picture of Instagram, and as we discussed, it can take more latency versus a live chat like this, which is more time sensitive and latency sensitive, versus somebody trying to manage remote fleet of vehicles, which is even more safe, which has become safety critical. And so, how do you differentiate between these types of applications in the back of the network, right? The backhaul, etc. And that's where the Ethernet network in the backhaul needed to step up in its ability to differentiate between different type of traffic being carried on the same fiber optics. And so there's a concept called time-sensitive network that enables this differentiation of different type of network. And what we have done is actually embedded this time-sensitive network protocols in the hardware layer in our Ethernet chip, as well as Ethernet switch chips, as well as enabled the timing-aware protocols in our MACsec and the PHY devices as well. And that enables this multiple different type of traffic carrying capability in a real time, and allows carrier to prioritize different type of traffic depending on what needs to be prioritized at that moment in the time. It's not even seconds. You're talking milliseconds and microseconds.
Okay. Okay, and since we're talking seconds and milliseconds, let's talk timing and synchronizations. And again, that's pretty broad. There's everything from just controlling a clock signal on a board to synchronizing across large geographical spaces between buildings and networks.
That's right. That's right. So if you look at that picture again, in timing and timing and synchronization technology, with 4G, what was happening was, you see one of the box on the left called DU, the base station or the radio, and that was synchronized with the core network. So the synchronization technology needed there was only implemented in 2 ends of the network, and that was good enough. And the amount of accuracy or error tolerance that was needed was also lower than what's needed for 5G. With 5G, you're going to have synchronization need for every one of these nodes in between, so that the entire network has much lower timing error through the end of the network. And that means you have to add synchronization at every single node in the network.
Right.
And that's something that we do very well. We provide not only the components but the software and technology that
Yeah.
goes from end to end.
Okay, so can you tell us a little bit more just about that? Let's use timing and synchronization again as the example, and how does Microchip wrap up all of that hardware and software and systems expertise to help our clients along?
Yeah, I think that's a really good point. It's actually one of the flagship solutions that we offer for the 5G. If you go to I think there's a slide, uh, next slide on the slide deck that we have. It shows a really good example. So we not only provide, let's say we provide the PLL, which does synchronization of our timing signals, which you can see on this diagram on the right side. And we have a very long history, 25 years long history of enabling very tight synchronization. But we think of it as at a system level on each box, and also we think of it at a network level, what our carrier customers have to deal with. And in order to make that end solution happen, when Verizon or AT&T or Deutsche Telekom or carriers like that are deploying their base stations, we help them make sure that the synchronization happens at end to end from all the way into their core of the network down to the radios. And in order to do that, we provide multiple components, as you can see on this diagram, but also we provide the software. So on the right, you're seeing a PLL chip called synchronizer that goes in a system. And then in the middle is a picture articulating a software solution. And that software can sit on one of our devices like a microprocessor or a FPGA that we offer, or it can sit on somebody else's processor or CPU. And alongside that, we provide the PHY device on the left side that you see, which does a very high accuracy time stamping unit. And surrounding that, we provide the different types of components.
Okay.
And so this is an example of how we go to market, providing the complete solution at all the different hardware pieces as well as the software pieces, and enable network layer.
Okay, awesome. Thanks, Neelam. All right, let's pause there. Thank you again for walking us through all that. It's a fascinating subject. I appreciate you sharing your knowledge there.
Yeah.
We'll go and see if we have questions from our viewers today. So the first question is, what about 6G? So I think, yeah, I was wondering that myself. Obviously, we're in a long rollout period, but I assume the industry is already thinking ahead to the next iteration of technology.
That's right. So as we talk about, LTE was a supposedly long-term 10, 15 years evolution, and so is likely 5G. And as we see 5G probably going to be deploying all the way to 2030 and maybe even up to 2032, 2034. But that doesn't mean everybody else is sitting idle, right? The people who are doing research in terms of what's feasible beyond 5G that is defined today. And so there's going to be something called 5G Advanced, which is going to be intermediate update on top of existing deployment on 5G. So let's say 5G Advanced, the timeline is something around 27, 28 is when we start seeing the deployment or upgrading of the 5G networks that already deployed in last 3 years. And 6G, there's a lot of research being done on 6G, and the timeline today looks like 2030 is when we'll start seeing some early deployment of 6G. Okay. What are the goals for 6G and how it will change the dynamics again? That's something being debated in standards organization across the globe today. As you can imagine, a lot of participants from carriers, from equipment companies, and also chip companies like us are discussing that today.
Okay, interesting. All right. Next question is, what is the impact to synchronization of the transition from 4G to 5G?
Oh yeah, so that was, we talk about one impact of that synchronization, which was about need for adding synchronization at every nodes in the network versus in this 4G, it was only two ends of the network. Uh, the the other big impact is the amount of error tolerance. So for example, uh, if you want to increase the bandwidth or number of connections by 10x, we need to split those airwaves or bandwidth available into more refined granular chunks. So every connection gets their own, dedicated time around it, or dedicated, depending on the frequency or time, how it's split. And that needs to be managed by much tighter synchronization. So the error bar that in synchronization, the error bar that was allowed for 4G has gone down by 10x into 5G. Actually, not 10x, more like 100x. And that has meant that not only we need to implement synchronization on every single node, but that synchronization needs to be a lot more tighter than what it used to be for 4G. Okay. And that creates challenge for equipment designer in making that happen. Thankfully, we have a great team of engineers who have been focused on this problem for a long time, and we make it more complete solution much easier to implement. But that's a challenge that we help solve. Yes.
Okay. So the next question is, can you provide any more detail about the solutions for addressing the challenges in spectrum utilization?
Yeah, so spectrum utilization is very, let's say, universal challenge in 5G. The most important way we address that is by offering this tighter synchronization, end-to-end synchronization, which then enables better utilization of the spectrum. Another way this is being addressed by industry is actually using AI.
Okay.
And it's funny enough, AI has to happen, right?
Yep.
And AI is actually being used many different places in the network in 5G, but specifically to utilize spectrum better, what is called channel efficiency solutions are being put in place, where AI is being used to detect how many connections are live at a given time on a given cell tower or a radio, and then accordingly allocate, assign, let's say, higher or lower bandwidth on a per connection basis to make that utilization more effective.
Okay.
So that's another example. And those AI algorithms are continuously evolving. And one way to implement those algorithms in the radio is actually putting an FPGA that we offer in a very, very low power FPGAs.
Okay. All right. And one more for you, Neelam. So this is from Ali on YouTube. So the topic here is, so this is an interesting use case, remote control of a smart car in a city. I think the question is, could 5G be used to support that, or would it be used to support that?
I would say not just could and would. I think it is absolutely essential to have 5G type of connectivity for such safety critical application. So again, 4G provides you bandwidth, but the 4G network has not been designed for these type of safety critical application. What happens in the back of the network, the reliability of the connections are not that well designed for safety critical. So 5G network or 5G connectivity is absolutely essential to make it a reliable connection.
All right. Neelam, again, thank you so much for joining us today and sharing your knowledge on this topic. To our viewers, thank you for taking some time out of your day to join us. Again, if you enjoyed the episode, please like and share it. Please visit us at microchip.com/designs-for-the-edge. You can see our previously recorded sessions, and you can sign up for notifications. Our next season will start in September. Next week at this same time slot, we'll be kicking off a new season of Coffee Break, our other live stream series where we talk about product lines, development boards, and different types of technology coming out from Microchip technology. Again, thank you so much for your time. See you next time.